You. Hello. Can I hear an hello? Oh, thanks a lot. Let me extend a warm welcome to everyone, and also let's say thank you that you are here and taking the time to being here. My name is Alex, and I shall manage this presentation now for the next 30 minutes. Believe me, I'm so proud to moderate DARC, because DARC is the #1 solution of augmented reality by Mercedes-Benz. And believe me, it's true. In the next 30 minutes, Christian and Daniel will present us the result by using state-of-the-art web technology with a fully integrated end-to-end approach and an innovative augmented reality software named? Thank you. Okay. Next, let's talk about Daniel. Daniel is a very much appreciated colleague of mine, and is since 27 part of the Daimler and now Mercedes-Benz Group, and part of the Virtual Competence Center by Mercedes. As a part of the Arena 2036, he leads a lot of innovation projects around VR and AR, but now his focus is only to be the product owner of? Thank you. It's also a pleasure to me to introduce Christian Stein. He's the CEO of the Threedy company, and after he gained some experience as a software developer in the gaming industry, he got part of the VCST department of Fraunhofer EGD in 2012. He became deputy head of the department and managed the process to prepare the spin-off Threedy in 2020. And now, both are here to present DARC. And now the applause. Before we start, just a few necessary information. Please put your mobile devices into silent mode. And that's everything. And now let's DARC.
Let's DARC. Would you believe we have never met before? Like, never? Okay, DARC. As everything nowadays, it's an acronym, meaning Digital Augmented Reality CAx. Usually, it used to be Daimler Augmented Reality CAx, but then the company changed and we didn't want to name the application Mark, so here we are. As you may have seen, the talk itself is named Drive Pilot for Augmented Reality, because this is basically what we want to do. A highly assisted, mostly autonomous system for augmented reality. And to bring this together as our vision, as Alex coincidentally just mentioned, our goal is to be the #1 augmented reality application at Mercedes-Benz Engineering. As a matter of fact, we're not the first. There have been many applications around augmented reality at Mercedes-Benz already in the last decades already, but we aim to be the first that really bring it into the broad productive line where augmented reality just is not there yet. But we don't do this because we think it's kind of cool, well, which it is, but we got a really impressive strategic impulse from our upper management. For one, if you've been part of the Digital Product Forum in the recent days, you have heard a lot about digital twins, and it's a matter of fact that augmented reality is an integral part of the digital twin world. On the other hand, from the same spirit, we got a call to action from our digital product board to bring together a lot of augmented reality knowledge and provide one standardized, consolidated application for all of Mercedes-Benz Engineering. But it's not only our top management that's giving us these tasks, there's also our users. These users, the same that have been in touch with augmented reality for the recent years, they gave us a lot of feedback. And as you can see on the slides, it's not always positive. The feedback itself is we need augmented reality, but the tracking sometimes doesn't work. The users don't know how they can provide their data. They really don't understand how AR itself is working. Or it used to work a couple of weeks ago, and when we have another session, it's not working anymore for so many different reasons. So our users told us AR is just not there yet. So it's our call to do so by providing DARC. From this feedback, we created various goals we had in mind. On one hand, you see the user-friendly data pipeline. This is the core thing. If we want to enable our users to bring their data into an augmented reality scenario with their actual hardware, then they need to be able to bring their very own data as they know this from their engineering tools. this needs to work on demand. We don't want to have data processing processes where we need to provide the data 2 weeks in advance, create everything according to the use case, and then be happy that there's a totally different scenario on site. We need to have it on demand. All of this needs to work on an engineering-based user experience, meaning we need to have a look and feel similar to our engineering applications, using terms our engineers use as well. And not only make it look fancy just because we can. This is honestly kind of a mistake we in our IT part do often. All of this obviously needs to be part of our end-to-end infrastructure. It doesn't make sense to do something just for us where we need a very individualized process. It needs to be integrated in everything else we do here in our company. Then on the other hand, we need to have a look at the state-of-the-art technology we want to use. And maybe you have a slight idea which technology we ended up using. Because for us, it doesn't make sense to use a technology, whatever it may be, which is already outdated by the end of next year. Doesn't make sense from a user perspective or developer perspective move. So we also had a look at the topic like multi-device compatibility, because the users, they don't want to provide different AR glasses or things like high-end PCs where they need some sensor or measurement arms to do augmented reality. It just needs to kind of work everywhere, and it needs to be scalable and ready for the future. And at the end of the day, it needs to be simple and fun, because even the best tool, it won't be applied in the real world if no one is wanting to use it. So we started by having a look at that broad world out there. Everything regarding augmented reality we had a look at, starting on the hardware side. There's so many cool things out there, but we focus for now on the mobile tablet solutions. Reason being, it's already available within the company. We can just go to our IT shop, get a mobile tablet, which is already securely integrated in our infrastructure and our ecosystem. So that's a really good start. On the other hand, software-wise, there's gaming engines, there's cloud solutions, so many cool things out there with lots of pros and cons. But at the end of the day, we decided to go with the company Threedy. On one side, they have a couple over a decade years of experience working with cat data. And what these guys have done in the past is absolutely impressive, to be honest. On the other side, they're already working with our company for 7 to 8 years already. So that means their technology is integrated into our infrastructure securely and stable. But before I go deeper into what we do at DARC with their technology, let's have over to Christian to tell you something about his company.
Yeah, thanks, Daniel, for having us. And I want to share some details about the company and then our technology Instant 3D Hub. So Threedy itself is a spin-off from Fraunhofer IGD in Darmstadt. We are considering ourselves visual computing pioneers. Visual computing is like the umbrella term for generating images from data, but also data from images. And this is exactly what we do in the augmented reality case. Threedy is almost 2 years old by now, but we are building on 25 years of experience, and specifically our core development team has been working together for almost a decade by now. Our goal is to make the use of industrial data very easy and simple so that you don't need any domain knowledge to build complex industrial applications on top of your data. And in our opinion, so far, technical limitations are the reason for our customers not really unlocking the full potential of their data to this point. Our main product is called Instant 3D Hub. It's a visual computing as a service infrastructure solution in the sense of a middleware. So there are APIs on both sides, allowing people to connect their data and to build their applications on top. We provide a broad feature set from our core, the visualization over digital mockup operations, collaborative sessions, and now more and more also VR AR solutions for digital products like DARC. At the core of our solution is a concept that we call 3D data virtualization, and it's the idea or the approach to make data and compute services available for applications without the need to actually transfer the data to the user's devices. This enables digital products to leverage very large and complex data without the need to explicitly convert it to fit certain format or size requirements. This makes any of the often even manual data reduction or simplification processes obsolete, and also doesn't result in any loss of the data quality. At this point, Instance 3D Hub supports over 40 input formats, from native cut over exchange formats to assets. And by moving from this pushing of data through pipelines to a reference-based pulling approach, applications really can work with the full data quality, and all required informations are only ever loaded on demand. All details of the original data are preserved and are then reflected on our APIs in a harmonized and unified way. And this allows then the application, if you think about the digital twins, to easily and dynamically connect any business information directly with a single source of truth to really get the most value out of the application. As Daniel mentioned, we are collaborating with Daimler or Mercedes since over 8 years now, and this really led to a deep integration in the IT infrastructure and hardening of the technology for the specific challenges. Building on this idea of data virtualization, we are able to really develop scalable visual computing services. And how this works, I want to explain quickly with respect to the rendering. So most solutions that you see on the market so far are using either server-side rendering that uses GPU resources on the server side to generate images, which are then transmitted as 2D image streams to the often thin client applications. This comes with huge costs, typically, if a large number of users needs to be supported to provide the respective resources on the server side, but also results in high bandwidth requirements for the 2D data streaming. The other approach we see often is that data is exported, packaged up, then transferred or downloaded to the client devices, which results in fat applications because all functionality needs to be implemented on the clients, and also the complex algorithms typically need to work on the full data set, at the end resulting in long waiting times for the export and download processes, and often limitations on the size of the data, because you have to consider from the beginning which resources will be available on your clients. Instead, our approach of hybrid 3D streaming is the idea, you can compare it a little to Google Maps, of on the server side in advance computing spatial structures to accelerate the further processing, and giving us the opportunity to dynamically distribute compute between client and server, in a sense splitting the algorithms over the whole infrastructure. And that way, if we think about the rendering, only transmit the visible surface fragments to be then rendered on the client device. And this concept is what we embrace for all of the features we are building on the technology. So we can also go into further detail if you are interested later on in how we scale the model-based tracking together with local SLAM algorithms for the results we can see in DARC. Overall, this leads to a way better resource exploitation, and thus for the customers also reduction of the operation costs. A final USP of the technology I want to share is the broad range of integration possibilities, from zero code to fully custom apps, while having all of these features available. We embraced extensibility right from the start when developing this new software generation, from the API layer to the web components. However, if we look at the customer integrations at this point, we see that the actual implementation range is rather binary. Either people integrate the prepackaged applications, embed them in existing tools, or they go for the full-fledged solution development. So in order to prevent our standard apps from becoming jacks of all trades and further bloating them from a user flow and feature and functionality perspective, we really encourage customers to build their own individual tool sets that they can tailor to their needs, and in the best case even flexibly combine. And for this approach, what we have seen with DARC, the concept of micro frontends, of bundling certain functionality through the whole software stack from the user interface to the services, is really the best fit we've seen so far. And Daniel's going to share some more on that.
Thank you, Christian. All right, so we used the Instant 3D Hub to create DARC. Basically, DARC is like a website. As you can see here, that's a picture like of any browser. But this gives us the power to provide DARC as an augmented reality solution anywhere, anytime, as long as there's internet available, which honestly, I think that's a fair request nowadays. At the end of the day, it also solves our multi-device request, because as long as any device is able to have a browser, it's able to load DARC, basically. Now, the core, everything that we need in DARC is around data. For this, we need a data pipeline that's as efficient as possible. And if you listen closely, you realize we are as close to the PDM system at Mercedes-Benz as we can be. All the data we have in DARC is streamed directly from our PDM system. This makes the data secure, this makes it easy to work with the data, and gives the users a feeling for what they're working with, because it's exactly the same they know from their everyday life. At the end of the day, we have a device, a mobile tablet, where the data is only streamed on. So even if the device is stolen, no data is left or lost, because nothing is leaving our premise. Cool, isn't it? Now, this is basically a first look at the DARC workspace. Keep in mind, it's like a website. And we focused, in terms of user experience, only on the 3 basic steps that we need for augmented reality. We need to load our data. Here, it's part of our structural beam. Then we need to select the data in terms of what's required for AR, because the core idea is we need to track something. In this instance, I want to track this object. I need to select in the software, OK, make this a tracking object. And then we just need to start and do AR. Ha! Just like my breakfast this morning, this is DARC. Nice one. Even though this is simple, it mentioned on the slide before, this solves basically 80% of our requirements. There's so much more we need to take care of. On one side, the whole web streaming thing needs to be future-proof, future-ready. If you've been part of the music or the movie industry in the recent years, I hope you agree that mobile streaming or streaming on demand is kind of here to stay. So there's no reason for us to believe that it won't work for our application. But it comes with a very, very big trade-off. We are only as good as the bandwidth we're having. So there's many things we try to improve in terms of bandwidth, not only for the image quality, but also for the AR tracking. Our augmented reality experience is only as good as the tracking. And since the tracking is used through the streaming service as well, we need to make as efficient use of the bandwidth as possible. For this, we try to increase different improvements for our tracking. For example, adaptive image resolutions. So when I move a lot around my part, say I would like to track this part here. If I move a lot, I don't need that much information for the tracking. Hence, I'm just sending many low-resolution pictures, so I can keep track of the big changes that are happening in my environment. If I'm close to my hardware, I'm just moving little steps. Then I want to focus on the finer details that are changing. That's why I'm sending less but more high-resolution images, making better use of our bandwidth that's available. And this is not a binary situation. We try to adapt this as fluidly as possible according to our needs. And there's many other cool things we're doing. But this will be in a later talk. I said already, we're going to cover 80% with load data, select AR, start AR. But of course, each and every use case have their very specific requirements. And we try to solve this in so-called MicroApps, or as Christian already mentioned, micro frontends. This is a really novel approach of how you can integrate different software components within each other. In our case, DARC serves as a so-called container application, meaning it's able to host other applications, so-called MicroApps. The blue one here you can see is one of these MicroApps. This can absolutely be developed independently of the container app, which gives us speed and stability and saves kind of a lot of costs in the development process. If we can just develop those parts individually of each other, and when we bring them together, they just work. Another cool thing, we can share these MicroApps over different applications that are using similar structures, like our container app. In our case, this means basically every application that's using an instant 3D hub is able to use the same MicroApps we're developing for DARC. So this gives us a broad coverage of use cases that we can serve within our company. Now, here we have a rough picture of our development process and our production pipeline. And we marked some of the spots there where we already have use cases where our users are using DARC. And honestly, there's many more to come. The cool thing about our solution is that we have an end-to-end data transition, meaning if we start with using our data in the beginning of this process, we can use the same data, we can use the same DARC projects throughout the whole timeline. It will be persistently available if the user needs it to be. And wherever we are in the process, our DARC application is available on demand. Now, we need to be honest a little bit. We need hardware to track this, so we're not saving that much on hardware cost. But with DARC, we can enable a lot of improvement in terms of time and quality regarding these hardware pubs, which in our opinion is a massive impact we're bringing to the table. Now, this is where we are now. Obviously, we want to go further. Currently, we just basically went from the POC to the MVP stage, and now we're in the beginning of a big rollout throughout the company. By doing so, we want to explore more use cases, create appropriate microapps for them. For example, there's a wiring harness topic, there's a welding point topic that we try to explore and bring all of these special requests into DARC through microapps. Then, the tracking, as I already mentioned, it's something that will be an issue for the ongoing years. We can always be just a little more better, and we strive to be the best in class regarding AR tracking. And I'm really sure we can do this. Can we?
Sure.
We can. The whole integration into in our Mercedes-Benz environment, even there we can improve. We can stabilize our integration. We can improve the performance, thinking about stuff like moving into the cloud, for example. This is something we're going to explore in the future. And one other thing, we're going to move closer together with all the other mentioned applications that are using the Instant 3D Hub as well. Because in our idea, it works really well if we try to find the synergies between those applications and improve on them. We're trying to interconnect them. Basically, we're creating the darknet. But we're not the only ones trying to improve. I think Christian has something to say as well.
Yeah, so there are obviously several topics on our roadmap, and some that are specifically relevant for the DARC environment is on an infrastructure layer, what we call a hub mesh. So the idea of really connecting multiple instances of Instance 3D Hub to not only share data, but to communicate between each other to find the best location to run a certain service, always with the idea to bringing the compute as close to the client user as possible. Secondly, if we think about the visual computing services, I think the extension for multi-model tracking is going to be most important. So this is the idea of really being able to independently track several subsets of your scene. And this enables you to not only measure their relative positions, but only automate things like a target actual comparison. So I think there's a lot of use cases already that might profit heavily from integrating this functionality. Finally, we will speed up operations on even larger assembly structures. Keyword here obviously is the variant snapshots at Daimler, where we are constantly trying to, as Daniel mentioned, improve general speed and performance of our system. To end this from the 3D side, although it's rather late, I think we are almost the latest talk today, so I hope you stay a little longer, and if you hadn't a chance yet, visit us at our booth 21B. Also, we have been part of several guided tours, and we're happy to share our contributions there if you didn't participate in the tour yet. And so much for talking, and now show some live action.
Yeah, let's talk. So the cool thing, if you have a stable software, you can just show it anywhere, anytime, and it's going to work. That's why we're doing this live. Let's wait for the signal through the HDMI to come up on the screen. As you can see, it stays dark. This is not in our control. Oh, this is the slides tablet.
Operator.
Dark, ladies and gentlemen.
Gucken wir
mal. Ist sie drin?
Okay.
Oder? Oh.
There we go. Achtung mit dem Kabel.
Okay, what you can see here is basically dark. The same thing I have here on my mobile tablet. I can interact with the data similar to what I can do in more or less any engineering tool I have. We brought this rim here today, and we could load the responsive CAD data if I knew the inventory number of this thing. So we prepared this session because I probably couldn't remember the number. Now here we select the tracking target. Since we brought this rim, we need to track the rim, and all we need to do, press start, wait for everything to load, and then we're good to go. Let's do it from here just to show that's kind of complicated. I cannot hold both things at once. Oh God, need to hold still, need to hold still. There it is. Applause. All right, now I'm superimposing this data here. Keep in mind, none of this data, no cat data, nothing, is here on the iPad. Everything is right now being streamed from our PDM system way over there in Sindelfingen. This use case itself is not so interesting. All I could do, for example, oh God, hold on, is cut this wheel. No, I cannot cut this wheel. Why can I not cut this wheel? Christian, why can I not cut this wheel?
It's your product.
It's my product. Okay. Not going to cut this wheel. Showing you something differently. The wheel itself is not so impressive since we have it here in real life. Oh, see, that's making it complicated right now for me to hold both things at once. That's why we do it live.
You're back.
Okay, now we bring parts of the wheel that are not here in the rim, say the tire or some of the bolts, the screw, or the air vent, which gives us an impression how it would look like in a finished product. It's getting even more interesting when we bring, for example, simulation data in here, like the streamlines. With this, we can have a look at the aerodynamic qualities of our whole wheel, the tire, the rim, everything. Now we could scale this up even more by bringing some pieces of the car in here. You can see it in the upper right corner. The data is loaded for being prepared for the stream, and then it's ready on demand. So here now I can walk around this car, get a really in-depth look of how the stream is behaving, for example, on the front part. We could scale this even up further by bringing the whole rest of the car into the scene. As you can see there, some parts are still being loaded from the PDM system, though this obviously takes some time since this is a massive data set. But still, yeah, this is DARC. And if you want to get a cool impression of how the object tracking works, now you can see here the car is more or less flat on the table. And if I move this around a little bit, it will adapt accordingly. And that's it. See, they're even applauding from the other room. Now, if you've been part of this digital product forum in the last days or even visited online, I'm sure you know that there's a really bright future ahead for the Mercedes-Benz Engineering. But in our case, you need to keep in mind the future is dark. Thank you very much.